In the realm of modern science, few facilities are as renowned or as enigmatic as CERN's Large Hadron Collider in Geneva, Switzerland. However, it has also been the subject of numerous theories and speculation, particularly regarding its potential to open gateways to other dimensions or create phenomena that defy conventional understanding. One recent event has added fuel to these speculations. A man claims to have captured images of a strange, portal-like object hovering above the collider during the night. This encounter, which the man documented with a series of photographs, has sparked widespread curiosity and concern, raising questions about what might really be happening at the world's most advanced scientific facility. The man at the center of this story, who has chosen to remain anonymous, is an amateur photographer and local resident of Geneva. Known for his keen interest in astrophotography and nighttime landscapes, he created a post stating that he often spends his evenings capturing the serene beauty of the night sky over the Swiss countryside. On one particular night, however, his usual routine of photographing the stars took a bizarre and unexpected turn. The man had set up his camera on a hill overlooking CERN, a location that offered a clear view of the sprawling research facility and the surrounding countryside. As he adjusted his camera settings and began taking long exposure shots, he noticed something unusual through the viewfinder, an odd, glowing formation in the sky above the collider. At first, he assumed it was an aircraft or some atmospheric anomaly, but as he continued to observe, the object's appearance and behavior defied easy explanation. The object, which appeared to be circular and surrounded by a swirling, mist-like aura, seemed to pulsate with a soft, otherworldly light. It hovered in the air, seemingly stationary, yet the light around it shifted and moved as if it were alive. The man quickly snapped several photos, each one capturing the strange phenomenon from different angles and exposures. The object remained in the sky for several minutes before slowly fading away, leaving the man both fascinated and deeply unsettled by what he had witnessed. The photographs taken by the man are striking and unusual. They show a circular formation in the night sky with a central glow that seems to radiate light in all directions. Surrounding the central glow is a swirling vortex-like structure, almost as if the object were a gateway or portal to another dimension. The light emitted by the object is soft but intense, casting an eerie glow over the surrounding landscape. The colors in the photographs range from bluish-white to pale purple, adding to the surreal and otherworldly appearance of the object. After reviewing the images, the man was convinced that he had captured something extraordinary, something that could not be easily explained by conventional science. He decided to share his photographs with online communities and forums dedicated to unexplained phenomena, hoping to find others who might have seen the same thing or who could offer insights into what he had witnessed. As the photographs began circulating online and to social media groups that investigate strange phenomena, they quickly attracted the attention of both enthusiasts of the paranormal and those interested in the cutting-edge science being conducted at CERN. The images sparked a wave of speculation, with various theories being proposed to explain the mysterious object. One of the most popular theories is that the object was indeed a portal, possibly opened by the high-energy collisions taking place within the Large Hadron Collider. Some believe that the collider, with its ability to accelerate particles to nearly the speed of light and smash them together at unprecedented energies, could inadvertently create rifts in the fabric of space-time. These rifts, according to the theory, might manifest as portals to other dimensions or parallel universes, explaining the strange vortex-like appearance of the object. Others have suggested that the object could be a manifestation of exotic particles or phenomena predicted by theoretical physics, but not yet observed. For example, the collider's experiments are designed to explore the fundamental nature of matter and energy, and it is within the realm of possibility that the object captured in the photographs was the result of such an experiment, perhaps a particle interaction or a rare event that produced visible effects in the sky. Skeptics, on the other hand, have offered more conventional explanations, such as the possibility that the object was a natural atmospheric phenomenon, like a rare type of aurora or a lenticular cloud illuminated by light pollution from the nearby city. Others have suggested that the photographs might have captured a reflection or lens flare, an artifact of the camera's optics, rather than an actual object in the sky. Regardless of the explanation, the photographs and the man's account have stirred considerable curiosity and concern, both within the scientific community and among the general public. For those who view the Large Hadron Collider with suspicion or fear, the images are seen as evidence that the facility is indeed tampering with forces beyond human understanding. These individuals worry that the experiments at CERN could have unintended consequences, potentially endangering not just the local area but the entire planet. For others, the photographs are simply a fascinating mystery, one that invites further investigation and inquiry. They see the images as a reminder that, despite all our technological advancements and scientific knowledge, there are still aspects of the universe that remain unexplained and mysterious. The possibility that the collider might be capable of producing such phenomena only adds to its allure and the sense of wonder that surrounds the exploration of the fundamental forces of nature. Interestingly, over the years, a number of people have reported mysterious glowing objects sighted above the facility during the night. These sightings have sparked widespread speculation, with theories ranging from natural atmospheric phenomena to evidence of extraterrestrial activity and even the possibility of unknown side effects from the collider's experiments. The strange glowing objects have been reported by both local residents and visitors to the area surrounding CERN. These sightings typically occur at night, with witnesses describing luminous orbs or streaks of light that appear to hover or move in unusual patterns above the complex. The objects are often reported to change color, intensity, and shape, adding to the mystery of their origin. While the sightings have varied in detail, the common thread is the appearance of these unexplained lights in the sky, seemingly linked to the presence of the LHC. One of the earliest recorded sightings occurred shortly after the collider was first operational in 2008. Since then, reports have continued sporadically, with several notable incidents in recent years. Witnesses have described the objects as having a distinct, otherworldly glow, ranging from bluish-white to reddish-orange, that sets them apart from ordinary aircraft or known natural phenomena. The objects have been seen both near the ground and at higher altitudes, and in some cases, they have been observed for several minutes before disappearing without a trace. The appearance of these glowing objects has led to a wide range of theories, each attempting to explain the phenomenon within the context of known science or more speculative ideas. One of the more conventional explanations is that the glowing objects are natural atmospheric phenomena, such as ball lightning, sprites, or other rare weather-related occurrences. Ball lightning, for instance, is a rare and poorly understood phenomenon that involves the appearance of a glowing spherical object during thunderstorms. While ball lightning is usually associated with stormy weather, some have speculated that similar electrical phenomena could be triggered by the LHC's massive electromagnetic fields. Sprites are another possibility. These are large-scale electrical discharges that occur high above thunderstorms, producing bright, short-lived flashes of light. However, sprites are typically red and occur far above the LHC, making them an unlikely candidate for the glowing objects described by witnesses. Given the Large Hadron Collider's role as a cutting-edge research facility, some have suggested that the glowing objects might be byproducts of the experiments taking place within the collider. The collider is designed to accelerate protons to near-light speeds and smash them together, creating conditions similar to those just after the Big Bang. These collisions produce extremely high energies, and it is conceivable that they could generate phenomena not yet fully understood by scientists. Some researchers have proposed that the glowing objects could be related to the release of exotic particles or radiation resulting from these collisions. Alternatively, they might be a visible manifestation of the intense magnetic fields generated by the collider. However, there is currently no direct evidence to support these theories, and CERN has not reported any unusual or unexplained side effects from its experiments that could account for the sightings. The Large Hadron Collider has not only played a crucial role in expanding our knowledge of the universe, but has also sparked interest among UFO enthusiasts, who speculate that its experiments may have inadvertently drawn the attention of extraterrestrial beings. Over the course of many years, a multitude of eyewitness testimonies and photographic evidence have surfaced, claiming to depict unidentified flying objects near the iconic collider. Numerous witnesses have vividly described observing brilliantly illuminated, saucer-shaped objects suspended above the facility, occasionally exhibiting extraordinary aerial maneuvers that seem to defy the known laws of physics. These intriguing reports originate from a diverse range of sources, including esteemed scientists, diligent researchers, and even local residents residing in the vicinity of the collider. These intriguing accounts have sparked widespread curiosity and debate among both experts and the general public, leading to a quest for deeper understanding and exploration of these fascinating phenomena. One notable account comes from a physicist working at CERN who reported witnessing a bizarre aerial phenomenon above the collider. Dr. Castaldo described seeing a UFO that emitted a pulsating light while hovering above the accelerator. He claimed that the object moved in ways that no conventional aircraft or natural phenomenon could replicate. His account, along with others, suggests that there may be something genuinely unusual happening in the skies above the Large Hadron Collider. The scientific community, while initially skeptical of UFOs, has adopted a more open-minded approach towards studying this intriguing phenomenon. In recent times, scientists have displayed an increasing interest in unraveling the mysteries surrounding UFOs, recognizing their potential as a legitimate scientific pursuit. This shift in perspective can be attributed in part to the disclosure of previously classified UFO-related documents by the US government. Furthermore, the establishment of dedicated task forces tasked with investigating UFO encounters has added a sense of credibility and legitimacy to the subject, prompting scientists to delve deeper into this strange realm. Scientists, known for their rigorous skepticism, are beginning to acknowledge that UFOs warrant serious scientific scrutiny. Given the extraordinary and distinctive location of the Large Hadron Collider and its undeniable relevance to the cutting-edge realms of physics, a number of esteemed scientists have put forward the suggestion that the frequent UFO sightings observed above the facility should be subjected to further exploration and inquiry. Their rationale lies in the belief that these sightings may potentially encompass a phenomenon that can unlock invaluable insights into our comprehension of physics, propulsion systems, and even the existence of extraterrestrial intelligence. It is well known that scientists stumble upon groundbreaking breakthroughs when they stumble upon unforeseen occurrences and meticulously analyze deviations from the norm. One of the primary factors that contribute to the consideration of genuine UFO sightings above the collider is the challenge presented in providing conventional explanations for these phenomena. Skeptics frequently assert that UFOs can be easily dismissed as misidentified aircraft, weather balloons, or natural occurrences. However, it is important to acknowledge that the collider is situated in a relatively secluded region, which significantly diminishes the possibility of confusing these unidentified aerial phenomena with ordinary objects. Furthermore, the presence of cutting-edge instrumentation and the profound scientific acumen demonstrated at the collider renders it highly improbable for trained professionals to mistake mundane objects for something extraordinary. Consequently, this reinforces the credibility and perplexity surrounding the purported UFO sightings above the collider. Through a comprehensive examination of this phenomenon, it becomes evident that further exploration and analysis are necessary to comprehend the nature of these encounters and determine their legitimacy. Furthermore, the flight attributes reported for the unidentified flying objects witnessed hovering over the Large Hadron Collider present a perplexing mystery, as they defy any explanation based on established principles of aerodynamics or propulsion. According to a report in Nature in 2015, the Large Hadron Collider, which is the biggest and most potent particle accelerator worldwide, is set to be reactivated in the upcoming days. Despite the global anticipation surrounding this event, there are two individuals who have chosen to keep quiet: Walter Wagner, a former nuclear safety official, and Luis Sancho, a journalist from Spain. They have involvement with the Large Hadron Collider and have decided to come forward with an interesting revelation. Months prior to the planned initiation of the particle collider in 2008, Wagner and Sancho took legal action against the entities responsible for this colossal device. The plaintiffs were the US Department of Energy, Fermi National Accelerator Laboratory, National Science Foundation, and the European Organization for Nuclear Research. It requires immense courage and, perhaps, a touch of irrationality to attempt legal action against any of these institutions, filled with some of the most brilliant minds in the world. This is even more challenging when it happens right before the completion of a $6 billion, 3-decade-long project. In the defense of Wagner and Sancho, They believed they were trying to prevent what seemed like an inevitable and devastating catastrophe. The Large Hadron Collider's potential to generate a miniature black hole that could engulf the Earth was one of their primary concerns. They expressed this worry in their legal action. They said that in due course, the entire Earth would be drawn towards an expanding micro-black hole, resulting in the transformation of our planet into a medium-sized black hole. Consequently, the Moon, satellites, the International Space Station, and other celestial objects would continue to revolve around it. The lawsuit was eventually rejected due to the men's inability to provide evidence of a believable intention to cause harm. Although their concerns were unfounded, considering that the Earth has continued to exist, despite the Large Hadron Collider operating for several consecutive years, it is essential to comprehend the safety aspects associated with utilizing the Large Hadron Collider for scientific purposes. Wagner and Sakos presented a lawsuit with 3 concerns. However, it is important to understand why none of these concerns should be a cause for worry. Black holes, which are immensely dense objects, have a mass range that can be as small as 4 to 200 million times the mass of our Sun. Although black holes are typically very large, it is theoretically possible for a small amount of matter, on the scale of tens of micrograms, to be compressed tightly enough to create a black hole. Such a black hole would be considered microscopic in size. Up until now, there have been no instances of the creation or observation of a minuscule black hole, including at the Large Hadron Collider. However, prior to its initial operation in 2008, Wagner and Sancho expressed concerns that the high-speed acceleration and collision of subatomic particles could potentially result in the formation of an extremely dense particle amalgamation capable of giving birth to a black hole. According to the renowned astrophysicist Stephen Hawking, there is an alternative theory that suggests that even if a tiny black hole were to be created within the Large Hadron Collider, it would rapidly break apart and would not pose any danger to the survival of our planet. Black holes, as understood in general relativity, are formed when massive stars collapse under their own gravity, leading to a region of space-time where gravity is so strong that nothing, not even light, can escape. Considering this, the likelihood of creating a black hole under the conditions found in the Large Hadron Collider seems unlikely, as the energies and densities achieved there are far lower than those in stellar processes. However, the black holes in question regarding the Large Hadron Collider are not those of classical general relativity, but rather speculative objects predicted in some theories of quantum gravity, such as string theory. These theories propose additional spatial dimensions beyond the familiar 3, and it is in these extra dimensions that microscopic black holes could theoretically form at the Large Hadron Collider. In these theories, gravity becomes much stronger at small distances than currently observed, allowing for the creation of micro-black holes when particles collide at sufficiently high energies. The energies achievable at the collider, while impressive by human-made standards, are still far below the levels typically associated with black hole production. Yet, if additional dimensions significantly alter gravity's behavior at small scales, black holes could potentially form at the Large Hadron Collider. Despite the theoretical possibility, there is no empirical evidence that such processes occur in nature, despite particles interacting at energies far higher than those achievable by the collider in cosmic ray collisions in Earth's atmosphere. Moreover, if these hypothetical black holes were created, they would be expected to decay almost instantaneously through a process known as Hawking radiation, posing no threat. Additionally, thorough safety reviews conducted by CERN and the wider scientific community have concluded that the Large Hadron Collider is safe. They argue that if such microscopic black holes could be created in particle collisions, they would also be produced by cosmic rays and would have already caused noticeable effects, which we do not observe. The cosmos, with its infinite expanse and myriad celestial bodies, often astounds us with its proclivity for spectacular events. However, certain scenarios elicit more apprehension than wonder, one of which is the hypothetical situation of a black hole approaching the Milky Way. Black holes are objects of extreme density with gravitational fields so powerful that nothing, including light, can escape. The consequences of a black hole's approach towards our galaxy would largely depend on its mass and trajectory. If it were a small black hole, like those formed by stellar collapse, It would likely go unnoticed unless it passed extremely close to our solar system, disrupting the orbits of planets and possibly leading to mass extinction on Earth. However, if a supermassive black hole, millions or billions of times the mass of our Sun, were to approach the Milky Way, the implications would be far-reaching and devastating. Our galaxy, like most, has its own supermassive black hole, Sagittarius A, at its center. The dynamics between these two immense objects would become crucial. An incoming black hole would start disrupting the outer regions of the Milky Way, causing gravitational perturbations that might send some stars hurtling into intergalactic space while pulling others into erratic, high-speed orbits. This disturbance would ripple inwards, significantly perturbing the galactic disk and potentially triggering a burst of star formation due to the compression of gas and dust. If the incoming black hole were to reach the central regions of our galaxy, it would engage in a gravitational dance with Sagittarius A. This binary system of two massive black holes orbiting each other would cause further chaos, flinging stars out of the galaxy or into the black holes. Eventually, gravitational radiation would cause the two black holes to merge in a violent event, sending ripples through space-time known as gravitational waves. Post-merger, the newly formed supermassive black hole would likely settle at the center of the galaxy. Depending on the energy and momentum carried away by the gravitational waves, the galaxy could either be left with a significantly disturbed but still recognizable structure or be torn apart entirely, its stars scattered across the universe. The effects on Earth would depend on our planet's distance from these cataclysmic events. At our current location, about 26,000 light-years from the galactic center, we would likely be safe from immediate harm, but might witness a spectacular display in the sky as the galaxy's structure is dramatically altered. However, it is important to note that such an event is highly unlikely given our current understanding of the universe. Black holes, while abundant, are spread out over vast distances. Furthermore, their movements are largely governed by the distribution of mass in the universe, making a direct collision course with our galaxy incredibly improbable.